Alright guys, on to section 3.3, function notation. How can you use function notation to represent a function? This is page 69 of your student journal. And really, when you have a function, you have an independent variable, dependent variable, you have a domain and range. All that's just another way of saying you have an x and a y. And if you look at this briefly, I said you always have an x and a y. What do you not see? Do you see an x? Yes, there are actually, in fact, two x's. What do you not see, though? You do not see a y. And in fact, the only thing that changes really is that this little notation takes the place of y. And the way you pronounce this is f of x, g of x, h of x, and j of x. Okay, but besides that, I mean, it's just function notation. It's literally the way you write it, but it's the same thing as essentially the same thing as standard. Look, the only difference is you have a y in one, then you have a function notation in the other one, f of x. So moving on to page 72, evaluate the function when. So evaluate just means evaluate, like figure it out. When x equals -4, 0, and 2. So this, when it tells you to evaluate, it's basically telling you to substitute. Substitute what? Well, for x, we're going to replace it with -4. So negative. You have to copy the negative sign now because it was there from the start. And I'm replacing x with -4 plus 4. So I have -4 is +4. 4 plus 4 is 8. So when x is -4, you could say f of -4, because that's what we replace x with, is equal to 8. And the ordered pair solution for number 1, I'm just going to type it in up here, is -4, 8. And I'm actually going to see if I got to resize this page or not. Let's see. Okay, that's better. So you're going to do that 3 different times for each of these problems. So it sounds kind of like a hassle, but really it's just to help you get into the good practice of substitution. So -0 plus 4 is 0 plus 4. So f of 0 is equal to -0 plus 4 is 0 plus 4 is 4. The ordered pair for that is you plug in a 0, so that's your x, and you get a 4, and that is your y. Clear it up again. And the last one is -2. Notice that every time I substitute for x, I'm placing parentheses around where x used to be and putting in whatever I'm supposed to. It's a really good habit. Later on in the course, you're going to have to substitute expressions. So it's not just going to be one number, and so you're going to have to do that in order to distribute that negative sign. Eventually, though. So we have f of 2 is equal to -2 plus 4 is +2. And in our ordered pair, that will be something like 2, 2. So we got 3 different answers, 8, 4, and 2. If you didn't catch that, just go rewatch that. So here I'm replacing x with each of these numbers and its multiplication. So you could just say 5 times -4. What is 5 times -4? -20. A positive times a negative is a negative. G of -4 equals -20. G of 0 is equal to 5 times 0. In fact, let me equals 0. So G of 0 is 0. And G of 2 is equal to 5 times 2 equals 10. So you should be able to notice that I'm replacing x with whatever number they asked me to, but it also happens, here where the x is, and you just multiply or as appropriate. So each of these problems is going to be 3 separate problems essentially. I'll do number 5 for you in case you're feeling lazy or maybe you just want to check your answers. The format will look like this. T of -4 is equal to 6 plus, and wherever that x is, you will just replace it with -4. If there's more than one x, you replace each x with whatever they're asking you to replace it with. -2, which equals to 6 plus -12, which is really 6 minus 12 minus 2. 6 minus 12 is -6. -6 minus 2 is -8. T of 0 is equal to 6 plus 3 times 0, which is 0 minus 2. 6 plus 0 is 6, minus 2 is 4. Lastly, 6 plus 3 times 2, times 2 minus 2 is 6 plus 6 minus 2 is 12, minus 2 is equal to 10. So our three inputs are -4, 0, 2, and our outputs are -8, 4, and 10. To put them in ordered pair format, it looks like you plug in a -4, you got a -8. What else did you plug in? You plug in a 0, you got a 4. And lastly, you plug in a 2, you got a 10. Those are the ordered pairs. This is what all the work looks like. I know I didn't write it, but hopefully that's just honestly neater for you and easier to understand. If it's not, you can ask your teacher to explain it, or you can ask me to explain it. Okay, so moving on. Let NT be the number of DVDs. So N of T, the whole thing, represents the number of DVDs. So the whole thing here is N of 0, but within that, T is the number of trips. So the whole thing here is the number, and that's 8. So the number of DVDs you have is 8, and the number of trips you have gone on is 0. So what does that even mean? Let me try and put this into words for you guys. If you've taken 0 trips, that means you haven't gone yet, right? So before going to the video store, you, or I guess you guys would say you already have 8 DVDs in your collection. This one should also be simple. How many trips is there? 3. Right? T is the number of trips. So this is the number of trips. This is the number of trips. 5 and 3, 7 and 2. And the number is actually just the number of DVDs. So after 3 trips, or the number of DVDs in my collection after 3 trips to the video store is 14. Or the number I have 14 DVDs in my collection after 3 trips to the video store. Here, the number of DVDs in my collection after 5 trips is greater than the number of DVDs after 3 trips. 5 trips greater than 3 trips. And remember, it's not just trips, but the number of DVDs. And lastly, let's see. I'm going to write this a couple different ways because, well, for your good. So the first one represents the number of DVDs after 7 trips, and you see a minus sign, so that's the difference. So the difference between the number of DVDs in my collection after 7 trips and 2 trips is 10 DVDs. Another way of saying this is that you take the number you had after 7 trips and you subtract the number you had after 2 trips, that equals 10. So in those trips, you ended up picking up 10 DVDs. It doesn't matter how many you got at each time, or maybe you all picked them up on it. It doesn't say that. It just says the difference between the two of them, after those number of trips, is 10 DVDs. So another way to say this is from the 2nd trip to the 7th trip to the DVD store, my collection grew by 10 DVDs. Alrighty. Hopefully that makes sense to you. If it doesn't, really, well, ask a teacher. If you insist on figuring it out on your own, just realize that it says N of T is the number of DVDs and T is the number of trips. So this little thing right here essentially represents 2 different things. One is the whole number of DVDs, and the number inside is a function. It's a function of the number of trips. All right. Find the value of x. So this again, this actually just goes back to chapter 1 in solving for x. So it tells you that b of x is equal to negative 20, and if it's equal to something else, that means you can substitute it. So here, instead of b of x, I'm going to say negative 20 equals negative 3x plus 1. And then you do your inverse operations and you solve for it. In this particular problem, don't forget to separate that so you can see the left side and right side. In this particular problem, you would subtract 1 on both sides to get negative 21 equals negative 3x. You would divide both sides by negative 3, and you get 7 equals x. So again, I'll put the answer there for you. But you should work it out. 7 equals x. R of x is equals to 33. So just like we did before, instead of this, we're going to replace it or substitute 33 in its place. So 33 equals 4x minus 3. And you work it out by adding 3 to both sides. Again, there's your barrier. Tell you which sides of the equal sign there are. M of x equals 2. These are all the same. The only difference is you're working with fractions. Guys, if you understand how to solve 8 and 9, you understand the concept. If you don't understand how to solve 10 and 11, it's just because you didn't learn fractions very well in middle school or whatever previously. And that's really not something for you to worry about. It's just in this class, you will pick it up. So again, I will show you just for those of you who need practice. I won't solve it here because if you need to, then it's pretty simple. You add 3 divided by 4. But the fraction part, I'm a little more sympathetic to because I know a lot of students have a tough time. So I'll say 2 equals. Well, now I can't do that anymore. Negative 3 fifths. Remember that the negative sign only applies to one number. Which number? It doesn't matter. It could be the numerator or the denominator. It doesn't matter. So we're going to add 4 to both sides. I got 6 equals negative 3/5 x. And to get rid of a fraction, you multiply by the reciprocal. So I'm just going to flip it. Negative 5 over 3 or 5 over negative 3, whatever you so choose, it does not matter. In fact, I will make this 5 negative because it doesn't matter. So I got 6 times negative 5 is negative 30, divided by 3 is multiplication. You multiply by the numerator and you still divide by the denominator. So 6 times negative 5 is negative 30, negative 30 divided by 3 is negative 10. All this mumbo jumbo just cancels out. We have negative 10 equals x. Again, this one, you add 3 and you would multiply by the reciprocal of 5/6 is 6 over 5. So what does that look like here? Let's substitute this for negative 18, or substitute negative 18 for w of x, equals 5 over 6 x minus 3 plus 3 plus 3 negative 15 equals 5 over 6x. Multiply the reciprocal, 6 over 5. That's a negative 15, so this answer is going to be negative 6 over 5. And you get, let's see, what do we get? So we get negative 18 is equal to x. This cancels. You'll do negative 15 times 6, and then you'll divide it by 5. All right, guys. That's it for section, what are we on? Section 3, page 72 in your student journal. Hopefully you understood it. Again, for function notation, really, it's just replace y with an f of x or an r of x or whatever. Nothing really changed. If you understood chapter 1, this section should come pretty simply to you. Thanks for tuning in. If you have any questions, ask your teacher or ask me.